What if the greatest threat to life on Earth isn't an asteroid, a gamma-ray burst, or a black hole, but a second star orbiting our Sun? For over 40 years, scientists have debated a bold and unsettling idea that our solar system might be part of a binary star system. Hidden far beyond the reach of our telescopes, a faint, dark companion star, named Nemesis, may be orbiting in the deep cosmic wilderness, disturbing comets and triggering mass extinction events on Earth. No one has ever seen Nemesis. But no one has been able to fully disprove it either. Today, we're going on a full deep dive, exploring the origins of the Nemesis hypothesis, the mass extinction cycles that inspired it, the failed attempts to find it, and the shocking new theories suggesting Nemesis might not be a star at all, but something far stranger. Let's begin. 1. The extinction pattern. In the 1980s, two paleontologists, David Raup and Jack Sepkoski, published a controversial discovery. After analyzing hundreds of millions of years of fossil data, they found a pattern. Mass extinctions seem to occur every 26 million years, almost like clockwork. This wasn't a small coincidence. It appeared again, and again, and again. If true, it meant something was triggering these events on a cosmic timescale. Earth itself doesn't have an internal cycle that fits this. Volcanoes don't erupt like a metronome. Climate cycles don't work in neat 26 million year rhythms. So scientists looked outward, into space. And they found a possible explanation: the Oort cloud, a massive swarm of icy debris surrounding the solar system. If something disturbed this cloud every 26 million years, it could send waves of comets raining toward Earth, increasing the odds of extinction-level impacts. But what kind of object could consistently do that? The answer some astronomers proposed was a companion star. A second sun. Invisible. Undetected. Orbiting so far away that it completes one revolution around the Sun only every 26 million years. And they gave it a name, Nemesis, after the Greek goddess of retribution. 2. What Nemesis would be like. If Nemesis exists, it wouldn't look anything like the Sun. It would be much smaller, much colder, and almost invisible against the background of the Milky Way. Astronomers believe Nemesis would most likely be 1. A red dwarf star, the most common stars in the galaxy. Dim. Long-lived. Hard to detect at great distances. 2. A brown dwarf, a failed star, too small to ignite fusion. Glows faintly in infrared. Practically invisible in optical light. 3. A black hole. Yes, some models argue Nemesis could be a tiny primordial black hole, left over from the Big Bang, exerting strong gravitational influence but producing no light at all. Whatever Nemesis is, if it exists, it must orbit at a mind-blowing distance, between 0.5 and 1.5 light-years from the Sun. That means Nemesis could be floating out near, or even beyond, the Oort cloud, passing close enough every few million years to destabilize comets, but far enough to remain unseen. And that brings us to the next question. If Nemesis is real, why haven't we found it? 3. The search for Nemesis. In the early 2010s, astronomers believed they finally had the technology to detect Nemesis. Infrared surveys. Space telescopes. Data from missions scanning the entire sky. The most important mission was WISE, the Wide Field Infrared Survey Explorer. WISE mapped the sky in infrared light, which should reveal brown dwarfs or faint red dwarfs hiding in the dark. The results? No star or brown dwarf matching Nemesis was found. Many scientists took this to mean the hypothesis was dead. But the story isn't that simple. WISE could detect brown dwarfs up to around 10 light-years away, but only down to a certain mass. If Nemesis were smaller than expected, colder than expected, or something non-luminous, WISE would never have seen it. More importantly, WISE could not detect primordial black holes, which produce no infrared signature at all. Cue the next twist. In the late 2010s and early 2020s, several new studies proposed that dark matter could include tiny black holes, ranging from asteroid size to planetary mass. If one of these objects were orbiting the Sun, we wouldn't see it. but we would feel it, gravitationally. Some astronomers believe such an object could exactly mimic the Nemesis effect. So Nemesis wasn't disproven. It simply changed shape. 4. The new Nemesis theory. By the 2020s, something unexpected happened. The Nemesis theory made a comeback. Not as a star. Not as a brown dwarf. But as a gravitational anomaly, something massive, dark, and nearly impossible to detect. 3 ideas stand out. A primordial black hole, tiny, dense, completely invisible, leftover from the Big Bang. If one were orbiting the Sun at a distance of 0.5 to 1 light-year, it could disturb the Oort cloud, mimic the extinction cycle, evade all infrared surveys. This is now one of the strongest candidates. B. A rogue planet mass object like the hypothetical Planet 9, but even farther out. Could be 5 to 20 times the mass of Earth. Dark, frozen, and nearly undetectable. Such an object could cause periodic perturbations without being a star. See a dead star remnant, a white dwarf or neutron star, cold, ancient, dim. If old enough, it would no longer emit detectable light. This scenario is less likely, but still possible. The point is, the spirit of the Nemesis theory survived even after WISE failed to find a star. Because the core question remains, why do extinction events appear cyclical? And what could cause such a pattern? Until scientists fully understand the Oort cloud, dark matter, and primordial black holes, Nemesis will remain alive as a scientific possibility. 5. Could NASA or JWST find Nemesis? Today, the search continues. The James Webb Space Telescope could, in theory, detect extremely faint infrared sources, but only for objects within a few thousand O. Nemesis would be much farther away. The European Gaia mission, however, is a game-changer. Gaia maps the positions and motions of over 1 billion stars with incredible precision. If Nemesis, or any massive dark object, is tugging on the solar system, Gaia might detect subtle gravitational deviations in nearby stars. And then there's upcoming missions: LSST, Vera Rubin Observatory, Nancy Grace Roman Telescope, new infrared sky surveys. These will push detection limits even further. Could Nemesis still be out there? Yes. Especially if it's a black hole, a rogue planet, or a very small brown dwarf. The truth is simple. The outer solar system is 95% unexplored. We have mapped the surface of Mars better than we have mapped our own backyard past Pluto. Nemesis could still be hiding in the darkness. 6. What if Nemesis is real? If Nemesis exists, what would it actually mean? Here are the most likely consequences. 1. Periodic comet showers. It would periodically send clusters of comets into the inner solar system. Most would miss Earth. Some might not. A Nemesis-induced comet storm could explain the Chicxulub impact, and others we haven't discovered yet. 2. It would reshape solar system history. We'd no longer be a simple single-star system. Binary systems are actually more common in the galaxy than single stars. Nemesis would rewrite everything we know about solar system evolution, planetary formation, long-term habitability of Earth. 3. It might be connected to Planet 9. Some theorists argue both could be evidence of a larger gravitational structure, a massive, distant system surrounding our own. Nemesis might not be alone. 4. It's totally possible we've already captured evidence: comet clusters, odd orbital alignments, unexplained gravitational anomalies. We may already have data pointing to Nemesis, we just don't realize it yet. 7. Conclusion. So, does Nemesis exist? Nobody knows. But here's what we do know: the extinction pattern is real. The outer solar system is largely unmapped. Not all massive objects emit light. And the universe is full of surprises. Whether Nemesis turns out to be a faint star, a rogue planet, a dark remnant, or a primordial black hole, the search for it pushes us to explore the most mysterious regions of our cosmic neighborhood. and one day, a telescope or survey might finally catch something moving out in the dark. Until then, Nemesis remains one of the most haunting possibilities in modern astronomy.